Reno, Nevada, January 1961. At a blackjack table inside one of the casinos along Virginia Street, a dealer is watching a man who does not look like anyone he has seen at this table before. The man is 30 years old, slight, wearing a suit that fits the way academic suits fit, correctly but without vanity. He is betting in a pattern that the dealer cannot immediately parse. Sometimes $2.50, sometimes $40. The amounts shift in a way that seems arbitrary, but is not arbitrary at all. The man is not nervous. He is not celebrating when he wins or grimacing when he loses. He is tracking something, counting something. And the dealer, who has been standing behind this table for years and has developed the instincts of his profession, knows that something unusual is happening, but cannot say precisely what. By the end of the weekend, the man will have turned $10,000 into $21,000. He will also have changed gambling forever. His name is Edward Thorp. He is an assistant professor of mathematics at the Massachusetts Institute of Technology. He has never worked in a casino. He has never been a professional gambler. He has spent the previous 2 years not at tables, but in front of computers, running calculations, building a mathematical model that nobody in the history of gambling had built before. A proof, rigorous and complete and verifiable, that the casino game of blackjack is not unbeatable. That under specific conditions, with a specific method applied with sufficient discipline and precision, a player can gain a mathematical edge over the house. That the house, in other words, can lose. Not by luck, by mathematics. This is the story of Edward Thorp, the man who broke blackjack, was expelled from every casino in Nevada, and then went to Wall Street and did the same thing to the financial markets. A man who looked at a system that the entire gambling industry had assumed was impregnable, found the crack in it that everyone else had missed, and walked through that crack with a briefcase and a slide rule, and changed the world on both sides of the casino door. This is not a story about a gambler. It is a story about what happens when a mathematician decides that the casino's assumptions deserve the same scrutiny as everything else. It begins in Chicago, Illinois, on the 14th of August, 1932. Edward Oakley Thorp grew up in the specific intellectual climate of a scientifically curious family during a period when science was reshaping the world at a pace that made curiosity feel like urgency. He was a prodigy in the quiet, sustained way that real prodigies tend to be, not a child performer demonstrating tricks for impressed adults, but a person for whom the mechanisms of the physical and mathematical world were simply and continuously more interesting than anything else available. He read widely and voraciously. He built things. He tested things. He had from an early age the habit of mind that distinguishes a scientist from a person who merely knows science. He did not accept conclusions because authority offered them. He tested conclusions. He wanted to know why. He completed his undergraduate degree at UCLA, then his master's, then his doctorate in mathematics. He was good in the specific way that earns you a position at MIT, which is to say, very good indeed, in a place where very good is the baseline expectation. He joined the faculty, moved with his wife Vivian to Massachusetts, and began the life of an academic mathematician. Research, teaching, the slow and satisfying accumulation of knowledge about structures that most human beings will never encounter, and most mathematicians find inexhaustibly rich. And then, at a faculty party in the late 1950s, someone mentioned a card game. The game was blackjack. The someone was a colleague who had been reading about gambling systems and who raised, in the way that interesting dinner party conversations raise things, the question of whether the casino's edge in blackjack was truly fixed and permanent, or whether it was, perhaps, susceptible to analysis. The question lodged itself in Thorp's mind, the way questions lodge themselves in the minds of people trained to treat every assumption as a hypothesis to be tested. He went to the library. He found the existing mathematical literature on blackjack, specifically a paper published in 1956 by 4 Army mathematicians named Baldwin, Canty, Maisel, and McDermott, who had used hand calculators to develop what they called the basic strategy for blackjack. Their work established that a player using optimal decision-making at every point in the game, hit, stand, double down, split, could reduce the house edge to approximately 1/2 of 1%. It was the best existing analysis of the game. It was also, Thorp understood immediately, incomplete. What Baldwin and his colleagues had analyzed was static, a game in which every hand is dealt as if from a freshly shuffled deck, with the composition of the remaining cards irrelevant to the optimal decision. But blackjack is not a static game. The cards that have already been played are removed from the deck and do not return. The deck changes as the game proceeds. And a changing deck means a changing advantage, sometimes favoring the house, sometimes, under specific conditions, favoring the player. This was the insight. Not the solution, the insight that there was a solution to be found. Thorp went to the MIT computing facility. The machine available to him was an IBM 704, one of the large scientific computers of the era, filling a room, requiring a trained operator, capable of calculations that would have taken a human mathematician years or decades to perform by hand. He formulated the problem in the language the machine could process and set it to work. What he was calculating was the effect of card removal on the player's advantage. Specifically, when the deck is depleted of cards with certain values, does the remaining deck favor the player or the house, and by how much? The calculation required analyzing enormous numbers of possible deck compositions and the corresponding optimal strategies for each. The computer ran through the calculations over many hours. The results were definitive. When the deck was rich in tens and aces, the high-value cards that produced naturals, that improve the player's position in doubling down situations, that give the player more options. The advantage shifted to the player, not marginally. In sufficiently depleted decks with the right composition, the player's edge could reach several percent, reversing the house edge not by a small amount, but decisively. The implication was clear and extraordinary. A player who tracked which cards had been played and adjusted their bets accordingly, betting large when the deck favored them, betting the minimum when it did not, would, over time, have a mathematical edge over the casino. This had never been proven before. The casino industry operated on the foundational assumption that the house edge was permanent and immutable. Thorp's calculations proved that it was not. He wrote up his findings. He submitted a paper to the Proceedings of the National Academy of Sciences, an unlikely venue for gambling research, which published it in 1960. The paper attracted attention in academic circles and, through the mechanisms of press coverage, a degree of public attention that Thorp had not anticipated, and that included a letter from a man named Emanuel Kimmel. Manny Kimmel was not an academic. He was a professional gambler and businessman from New York, a man who had spent decades in the world of numbers and risk and who understood, when he read about Thorp's paper, that the professor had found something real. He wrote to Thorp and proposed a test. Kimmel would provide the bankroll. Thorp would apply his system. They would go to Nevada and find out whether the mathematics worked outside the computer. The meeting between the MIT mathematician and the professional gambler was one of those collisions of worlds that produces genuinely historic results. Kimmel provided $10,000. He also provided, in the rental car on the way to the casinos, the kind of practical gambling education that no academic preparation could substitute for. How casino personnel behave, how to manage attention, how to move between tables. The physical and social mechanics of sitting at a blackjack table for extended periods without attracting the wrong kind of interest. They went to Reno first, then to Lake Tahoe, then, in subsequent trips, to Las Vegas. Thorp played. He used his system, a method he had refined from the computer calculations into a practical counting approach, tracking the density of high cards in the remaining deck and adjusting his bets accordingly. The bets varied dramatically. The minimum when the count was neutral or unfavorable, multiples of the minimum when the count indicated a player advantage. The system worked. Not perfectly, not in the frictionless way of pure mathematics, because the casino floor introduces variables, shuffling patterns, distraction, the physical and mental demands of simultaneous counting and play, that the computer simulations did not include. But statistically, measurably, and undeniably, across the sessions in Reno and Tahoe and Las Vegas, Edward Thorp won. He won consistently enough that the mathematics behind the results was not in question. He turned the $10,000 into $21,000 across the first extended weekend of play. The casino had lost to a mathematics professor who had arrived with a system derived from an IBM computer and a paper published in the Proceedings of the National Academy of Sciences. The casinos noticed. Not immediately. The initial suspicion was less precise than suspicion usually sounds in retrospect. What the dealers and pit bosses noticed was the betting pattern. A player who bets $2.50 on most hands and then suddenly bets $40 is exhibiting a behavior that has no innocent explanation from the casino's perspective. The swing from minimum to maximum is the signature of a card counter, and once you know what you are looking for, it is visible. The response was escalating and eventually comprehensive. Individual casinos began to shuffle the deck more frequently, not waiting until the cards ran low, but reshuffling at the midpoint or earlier, destroying the count that Thorp had accumulated. They introduced additional decks. They sent pit bosses to stand directly behind him and watch his hands. They dealt the cards face down rather than face up. They barred him outright, in some cases, a practice that was legal and that casinos were beginning to apply with increasing conviction as the word spread through the Nevada gaming community that the MIT professor's system was real. At one casino, the personnel were so alarmed by his winnings that they began shuffling after every hand, a practice that rendered card counting impossible, but also slowed the game to a pace that was impractical for normal casino operations. They were disrupting their own business to stop a single player. Thorp wore disguises on subsequent trips. He wore wigs. He wore prosthetics. He changed his appearance before entering casinos where he had previously been identified. He was playing what was, in effect, a cat-and-mouse game with the Nevada gaming industry, armed with mathematics and a theatrical supply of disguises, and he was winning the game even as the casino countermeasures made individual sessions increasingly difficult. He was also writing. The book was published in 1962, Beat the Dealer, a winning strategy for the game of 21. It was published by Random House, and it did something that books about gambling had not previously done. It was mathematically rigorous. It presented in accessible prose, supported by precise calculations, the full basis for card counting, the logic of it, the mechanics of it, the specific systems that a player could learn and apply, and the conditions under which those systems generated a mathematical advantage. It sold. It sold in a way that academic mathematics books do not normally sell. It went through multiple printings. It reached the New York Times bestseller list. It was read by people who had never previously thought about blackjack in mathematical terms, and it was read by people who had spent careers in the casino industry, and its reception in those two audiences was entirely different. General readers were fascinated. Casino executives were alarmed. The Nevada Casino Control Commission, the regulatory body governing the state's gambling industry, convened emergency meetings. The reaction was not measured. The industry's first response was to change the rules of blackjack itself, restricting doubling down, altering the conditions for splitting pairs, modifying the game in ways designed to eliminate the edge that Thorp had identified. The rule changes were implemented rapidly and generated an immediate backlash, not from academics, but from ordinary players, who understood that the rule changes were unfavorable and stopped playing. Casino revenues fell. Within weeks, the rule changes were reversed. The casinos reverted to the original rules and instead intensified their operational countermeasures. More decks, more frequent shuffling, more vigilant identification, and barring of suspected counters. It was a tacit admission that they could not change the mathematics, that Thorp's analysis was correct, and that their only option was to disrupt the conditions under which the mathematics could be applied. The book created something else, something the casino industry could not disrupt by shuffling more frequently. It created a community. Beat the Dealer reached readers who were capable of applying its principles, who had the mathematical aptitude and the discipline to learn the counting systems and the emotional control to apply them under casino conditions. Some of those readers went to Nevada. Some of them won. Some of them formed teams, coordinated groups of players who worked together, with one player counting at the table and another betting large when signaled, distributing the counting work across multiple people and making the pattern harder for casino personnel to identify. The team approach reached its most organized expression years later in the famous MIT blackjack team. Groups of students and alumni from the Massachusetts Institute of Technology, who trained together, developed sophisticated team protocols, and visited casinos across the country and around the world in coordinated operations that extracted millions of dollars from the houses over a period of decades. They were operating in the world that Thorp's book had created. He had handed them the blueprint. They had built a structure from it. None of this was illegal. This is the point that the casino industry always found awkward to articulate publicly. Counting cards in your own head, with no external device and no collusion with casino personnel, is not against any law. It is not cheating in any formally recognized sense. It is simply the application of a specific cognitive skill to a publicly available game. The casino has the right to bar players it suspects of counting, and it exercises that right extensively. But the player who counts has done nothing that any court has been willing to call criminal. The casinos, in their resistance to card counting, are resisting intelligence. They are insisting that the house edge they established is a permanent arrangement that players are obligated to respect. Thorp's contribution was to establish permanently and publicly that it is not. The house edge is a mathematical construct that exists under specific conditions. Change those conditions, specifically, change the composition of the remaining deck, and the edge can shift. A mind capable of tracking that shift can exploit it, that is all. Thorp's subsequent career moved largely to Wall Street, where he applied the same principles to financial markets with results that were, in their own way, as revolutionary as Beat the Dealer. He co-wrote Beat the Market in 1967, which developed the first mathematical framework for warrant pricing, a precursor to the options pricing work that would eventually earn Fisher Black and Myron Scholes a Nobel Prize in economics. He founded a hedge fund, Princeton Newport Partners, in 1969, which generated consistent positive returns for years using quantitative strategies derived from the same mathematical reasoning that had beaten the blackjack tables. He was, in the fullest sense, a man who looked at systems that everyone else accepted as fixed and found in them the same thing, the exploitable pattern, the crack in the assumption, the place where mathematics contradicted common belief and the mathematics was right. Whether the system was a blackjack table in Reno or a warrant market in New York, the approach was identical. Define the variables, run the calculation, identify the edge, apply it with discipline. He published his autobiography, A Man for All Markets, in 2017 at the age of 84. The book traced the full arc, from the IBM 704 at MIT to the hedge fund offices of Princeton Newport, with the clear-eyed, methodical prose of a man who has been thinking carefully about things his entire life and has gotten very good at explaining them. It is the rarest of documents, a memoir by a person who actually did what he said he did, who can show his work and whose work checked out. The casinos that barred him in the 1960s are mostly gone, replaced by newer properties in an industry that has grown to a scale and a sophistication that the Nevada gaming establishment of 1961 could not have imagined. The rules have changed. Multiple decks are now standard. Continuous shuffling machines have been introduced in some properties. Surveillance technology monitors betting patterns with a precision that human pit bosses could never achieve. The industry has spent 60 years building countermeasures against the world that Thorp created, and the countermeasures have been largely effective. Card counting at a modern casino against a 6-deck shoe dealt by a dealer with instructions to shuffle at 60% penetration while cameras track your betting variance from a surveillance room. This is not the environment of the Reno casino of 1961. The crack that Thorp walked through has been narrowed, but it has not been closed. Card counting is still possible. It is harder, slower, less profitable per hour than it was in Thorp's era, but the mathematics has not changed. The deck is still depleted of cards as the game proceeds. The depleted deck still carries information. A mind that tracks that information still has an edge. The casinos know this. They manage it. They live with it the way you live with a structural fact you cannot change, by minimizing its impact without pretending it does not exist. Edward Thorp is in his 90s now. He is, by the accounts of those who know him, entirely himself. Sharp, curious, methodical, still interested in the next problem. He does not gamble in any serious sense anymore. He did not gamble in any serious sense in the 1960s either. What he did was apply mathematics to a problem that happened to be located on a casino floor, and the mathematics happened to be worth money, and the money was secondary to the proof. The proof is what mattered. The proof that the assumption was wrong. The proof that the house, which had operated for decades on the comfortable certainty that its edge was permanent and unassailable, had made an error in its arithmetic. Thorp found the error. He published it. He demonstrated it in Reno in January of 1961 with $10,000 of Manny Kimmel's money and a mine that the casino had no defense against. The wheel keeps turning, the shoe keeps running, the count keeps changing. And somewhere in the mathematics of it, an edge still exists. It always did. It just took a professor from MIT to find it.